Hi, this simulation is an expansion on work by Mora, Lorenzo, and De Pablo from their paper Biocultural Interactions and Demography During Middle to Upper Paleolithic Transition in Iberia, an agent-based modeling approach. In their paper and simulation, these authors developed a migratory model in which anatomically modern humans moved into Iberia, displacing and interbreeding with the Neanderthal population there. These authors considered the differences between land and sea, allowing their agents to move randomly from a set home location. However, in the initial paper, they did not consider differences in elevation or other land features. My simulation improves on this by adding a height map, and this can be done by changing from terrain type, land sea, to height terrain. Hitting the setup, we see that the map is turned to a grayscale, where darker colors represent higher elevations, the highest elevations being the Pyrenees Mountains between Spain and France. Features on the left side of the screen are from the initial model. These include the starting numbers of Neanderthals and anatomically modern humans, including birth rates, death rates, and movement radiuses for both, as well as birth rates and death rates for hybrids. Population boundary affects the starting location of Neanderthals and modern humans. This can be seen best with the land-sea map. As agents are more visible here. As this slider is moved up, humans start further north into France, and at about 256 or so, they are north of the Pyrenees Mountains. Avoidance is the preference that each agent will have to mix with either an agent that is a similar genetic makeup to it, or something more different. Finally, we have the maximum number of generations. Movement is modeled by having each agent move in a random direction from its starting point at the time step. The agent will move in that direction until a movement cost function is exceeded. Movement cost can be based on a log scale, based on the height of the patches that the agent moves through, or a linear scale. We can adjust this further using the terrain impedance. Terrain impedance is effectively a constant, so that higher impedance means agents can move smaller distances for each time step. At a 50, agents can effectively move just a single patch, whereas at a 1, they are less inhibited by terrain. And this is the model. We see that anatomically modern humans diffuse into Iberia, and as this happens, the agents start to mix. Initially, we have Neanderthals represented by 1, and anatomically modern humans represented by an 8. As the agents move and diffuse together, we get a mix. A number of agents turn from purely Neanderthals to a number 2 hybrid, whereas similarly the number of humans drops down while the number of other hybrids increases, though to a lesser extent than the number 2 hybrids. Changing this to my simulation and my improvements, adding the height terrain. Here, darker areas represent higher elevations. Running this, we see that the populations take longer to diffuse together. This result makes a lot of sense because we've essentially stuck a large barrier between the two populations, the Pyrenees Mountains. An additional map I have developed here represents same elevation map, but with expanded land areas to represent the lower sea levels during the Paleolithic. Note that this is an approximation and not based on an exact map as the elevation map was. Running this, we get a little bit more mixing here, but partly with this model, agents move randomly, as with the original. And so intelligent behavior like following the coasts is not something that these agents can do, and would be an excellent improvement on this model. An interesting thing that I found with this improved model, with the height map, is that this induces a number of barriers, not just the Pyrenees Mountains, between the Neanderthals and anatomically modern humans. Once the humans pass through the Pyrenees Mountains, either through Basque Country or Catalonia, they enter a second bottleneck here that they have to pass through again, either going further south or further west. So these multiple bottlenecks do mean that populations do stay separate for longer periods of time, and was interesting noting that the Pyrenees are not the only bottleneck between populations. Future work that would be interesting for this model would be to develop a more realistic Paleolithic terrain map. Again, the map here is an approximation, and another interesting feature would be to add preferential movement so that agents choose to move into directions that are easier rather than in a random direction, and additionally adding a second layer onto the map that models the carrying capacity of the specific region. And perhaps adding more intelligence to model movement, having agents choose to move into directions with higher carrying capacity, representing more plentiful food and easier conditions. This has been my model. Thank you for your attention.